¿Vale? Hola, buenas tardes a todos, muchas gracias por asistir y muchas gracias a ti también, Dani. Os presento a Dani, CEO y co-founder de Recog Analytics, una startup especializada en proyectos de investigación aplicando inteligencia artificial a desafíos del sector salud. Así que nada, presentaciones hechas, te cedo la palabra y muchas gracias de nuevo por venir al MIR.
Perfecto, genial, pues nada, muchas gracias Nuria por la introducción. Bueno, si alguien lo está viendo online y tiene cualquier duda, me piden hacer la presentación en inglés, entonces la vamos a hacer en inglés, pero cualquier cosa que os llame la atención o que no entendáis, me contactáis sin problema, que supongo que dejaremos mis datos de contacto y ya lo revisamos. ¿Vale? Entonces, without further ado, who are we? Recog Analytics, as Nuria said, we're a startup focusing on getting the most out of medical data to the benefit of the patient. Okay, and this is really our vision. So we want to be known by any biotechnology company which is developing drugs or which is researching how to improve patient diagnostics or predict the progression to analyze which treatment might be best suited for a patient. Well, we want to for them to think of us first when they want someone to analyze their data and actually draw value from it so that they can use it really in their day-to-day operations. Okay, so how did Recog come to be? This is the founding team. I'm Dani, I'm the CEO. I come from Asturias. I have an engineering background, and then I worked in technology and finance, and as a mix of product management and business development. My co-founder and CTO, Alberto, he is the artificial intelligence machine. So he's really the intelligence behind all of the artificial that we have at Recog. He's also an engineer. He's right now finishing his PhD in machine learning. And he also worked as a software architect for a major bank. So everything AI, cloud, big data, that's our guy. And last but not least, Carlos, our CEO, he's really the puzzle piece who fits everything together, because this guy, he's really smart. He studied at the same time medicine, physics and mathematics, and since medicine took longer, he decided to do a master's in AI while he finished. So he's the person that speaks both the language of the doctors and our language. And that's really important for us because, of course, when you come as engineers into a hospital, you are really not talking the same language, and we need him to translate from one side to the other. Now, together we started this company, as we were saying, to provide those research services, those data analytics capabilities to hospital, to clinics, to university, so that we can draw that impact from the data. And how do we do that? With those basic AI research. I will give you some examples afterwards of what we've done already. We also do medical app development, because what we saw is, okay, we can focus only on research, but there's still a lot to do to get that research into a productive setting. And we really wanted to move away from just doing the research and then it gets lost in some nice article somewhere, but it's not used. So for us it was really important that directly we can offer the full service, so that AI model or whatever we develop can be directly integrated into a hospital workflow, into a clinic software, and that then can be used productively. So we also included the data integration. And with what sort of data do we work? I'll give you again examples, but it's basically everything from images like radiology or images of the eye fundus, to all of the clinical history of a patient, to signals like brain waves. We analyze all of that to draw the significant insights that we're looking for. Now, a bit more into the detail of how we usually start to get to know our clients. So what we usually do at the first meeting is to just brainstorm together and understand what data does our client work with. Do they have already some initial ideas of where they could see potential? Like, we get this all the time. Like, I suspect that there is some relationship with the degree of progression of Alzheimer's with this and this clinical variable that we have, or this particular frequency in the brain waves, etc., etc. So a lot of our clients already have suspicions, and if that's the case, we check if that could make sense. We see whether they have their data available, where does that data come from. We take a look at all of the different needs that we find around that data. So probably it's incomplete, it might be of lacking quality, you need to pre-process a lot of that data to make it really useful. And sometimes you also find that you might have some bias directly included in your data set without even thinking about it. So you at least need to understand that you have that bias so that you can either correct it or take it into consideration, so that when you publish results you actually know that it's not valid for all the population, but you have some bias there in your model that needs to be taken into account. Once we have that, we develop the different AI models. I'll show you our framework on how we do that in a second. And as I was saying, we take into consideration ethical developments during all of the process. And what we saw is really important is that you always need to create an interpretability layer. Like AI, maybe you are engineers, maybe you are already more or less versed in AI and you understand the concept of the different impacts and variables in different models. Of course, this is not the case for doctors. So AI for them is just this black box. They don't know what it's about. So it's really, really important that every model, everything you say, comes with an explainability. So some AI models, as you might know, come with this intrinsic explainability. So already from how they work, you already get to understand more or less what is happening, like with a single decision tree, for example. In others, like if you go already into random forest, XGBoost, you can create that relative power of variables to understand, okay, what are the features that are accounting for this prediction, right? So what are we really, what is the causality of the data? If we make a prediction, what is causing that? Or if we are talking about images, imagine a radiology of the lungs of a patient and you want to know whether they have COVID. So of course, if you just give a prediction like, yes, they have COVID with a 90% probability, why? Like, no doctor could use that. And right now, I tell you this, in medicine, no AI is allowed to make an autonomous assessment, like a diagnostic. It's not possible. So there will be always a doctor signing that preliminary diagnostic, and then it's the doctor's head on the line if something goes wrong. So it's really important to have it interpretable. And for example, in images, what we do is we create this heat map where it tells you, okay, what is the deep neural network really focusing on when analyzing that image. Okay, so what does our framework look like? As I was saying, first thing is we analyze the data, we see what is available, what are the general objectives. This is even before we apply that framework. We do that exploratory session with our clients. Once we've focused on one particular topic, we define together the objectives that we want to arrive at from a business point of view. So what impact do we want to create on the patient, or what do we want to achieve with the drug development? Do we want to reduce the amount of patients in my clinical studies because it's too much, or do I want to optimize and focus on some specific sort of patients, etc., etc. So that's what we define. Then we do all of that cleaning process, which I already described at the beginning. We build the AI models, and to do that, of course, this depends heavily on the data we're working with, right? So it's not the same if we get some tabular data set as if we get the images with the radiology. But in general, we have already a predefined set of different models integrated into a pipeline that we have developed ourselves, coding. So what it does is, at the beginning, it runs through a lot of different models, but rather quickly, not without going into the biggest depth. So to give us an initial understanding of what models could perform best if we don't already have an intuition, because depending on the data set, you might already know, okay, this is probably a case for an XGBoost, or this is a rather small data set where with bias we can move on, for example. But in general, we try out a lot of different models, and then we take the most promising ones, and then we dive deeper into those, and we fine-tune them, and we work a lot to get the best results with the most promising candidates from that step. And we perform, which is really important, a very strict validation, considering the biases that I mentioned before, but also biases that we might be integrating during this pipeline, we take that into account to make sure, okay, that we are not introducing biases or training too much, using the test set over and over again, so that we reduce the risk of really overfitting our model to the data that we have available. And finally, as I was saying, we have the results, where we have those standard layers of interpretability, and we also provide all of the data in different formats, as reports, as dashboards. So I was saying our objective is that the results of our AI models are useful to the doctor or to the patient, so we really need to show that in the best possible format, so that it's also user-friendly, and they don't just say, okay, this was a nice scientific result, but no one will use it. So that's what we want to move away from. And with that, we also prepare to next steps. Depending on the project, it might be either going into further research, because we need to work more, to gather more data, to gather more insights, or it might go already into a productive setting. So what do we have to consider here? We need to consider the regulatory requirements, we need to consider a lot of safety and IT requirements, cybersecurity, a lot of things that we would need to consider in that case. Now, let me give you a couple of examples of some success cases that we have already developed together with our partners, which you can see on the left-hand side of the slide. And you see that we have quite a bit of focus and success already with ophthalmology, and in particular with two diseases that are really prevalent in society, so we consider that we can have a huge impact. One of those is in diabetic retinopathy screening. This is, you might have heard about this use case with AI, because there's a big public database that can be used. But we've taken that database and we've enriched it with 2,000 or 3,000 actually, 3,000 patients nearly from one of our partners, to increase the capability of the model, and also make sure that it can be adapted to the Spanish system. And then we have developed the model with a different philosophy than most of our competitors in this space. So usually a lot of the models tend to optimize for accuracy, so they tend to have like a decently high sensibility and a decently high specificity, but we really optimize the model for optimal sensibility, because one thing that you don't want in medicine is to have a false negative, right? So that's really what you avoid at all costs. Here again, our co-founder Carlos comes into play, because if you talk to doctors, they will tell you, no, we are really looking for really good specificity. But what they are actually meaning is, we look for really good specificity subject to the fact that we have perfect sensibility. So okay, since they don't know that there's a trade-off, and that if you have really high sensibility and you cannot get the best specificity at the same time, so we're not really talking the same language, and we need to interpret that and take that complexity out of the equation to build really the model that is useful in a clinical setting. Another cool use case was with glaucoma progression. Here we have an article coming out late this quarter or early next quarter. Really managed to get very accurate prediction of the progression of a glaucoma patient with a particular treatment, based only on data from 1 month after a treatment. These patients, they were screened for 6 years after the treatment, and they really don't know whether the effect is that good or that bad of the treatment. And now we have managed to predict whether they will progress with nearly 90% accuracy based on only 1 month after a treatment. Like, grasp this implication. You could have all of those patients, instead of treating them wrong for 6 years, you can already know after 1 month whether that treatment will be successful with relatively high accuracy, and then adapt the treatment and take a different one. So we're really excited for this use case, and we will be working more along that direction to support other treatments and to extend it to a bigger population as well. Another cool example was predicting breast cancer relapse. So when you have cancer and you get cured either by chemo, radiotherapy, or by surgery, or a combination of them, you need to obviously be monitored afterwards, right? And this monitoring happens with a different frequency depending on different risk factors. But this is really rudimentary at the moment. It just depended on the subtype of the breast cancer that you have and some other 2 or 3 considerations from guidelines which are like 30 years old. So we really thought there has to be a better way to do this, and we started to integrate a lot of different data from the clinical register of the clients, including the tumor size, the grade, what treatment was performed, age of the patient, etc., etc. And we bundled all of that together in a new model, which gave actually improved results as to the risk of that patient relapsing, so that you could adapt that clinical workflow and say, okay, this patient is really high risk, so I really need to monitor them very closely. Maybe they need to come in once a month, whether these patients are more or less risky, so we can leave them in peace also during half a year. And that's really also very important for the patient lifestyle, right? Because it's not the same like having to go every month to the doctor thinking, worrying about it. It's really beneficial to also reduce the charge that they suffer in that sense. So here again we're trying to move forward and see how we can further develop that use case with further partners inside of Spain. This is another cool solution that we have, and this works with brainwaves. So we already had the 3 different data types in there. The diabetic retinopathy, we do it based on images. I'll show you in a minute because I have a demo for that. The glaucoma and breast cancer was based on tabular data sets, and now we have one based on signals, so no matter the data type we can make use of it. And here the idea was, currently neurophysiologists, they're wasting a lot of time doing sleep studies and actually looking at that signal and saying, here you were in a REM phase, here you were awake, here you were in a sleep stage 2, etc., etc., and they spend hours doing that. So of course there's a better way. We got it. We have AI algorithms that can analyze those signals and actually quite accurately can predict the different sleep stages of people, so that we can automate that process with a high accuracy, because algorithms like that exist in the current software that they have, but they are not precise at all. So they just take it, throw it in the bin, and do it themselves manually. Our objective is, okay, we just integrate it, our solution works, you can use it, you no longer need to spend time on that, and you can focus on where you add value. Now we're also having a look at automatic epilepsy detection. So that's also another thing that is done during studies, and as I was saying, these studies are like really long in time, and imagine going through a signal that is like 8 hours long or sometimes even 24 hours long, saying, okay, this is a spike, then moving forward. Takes really a lot of time, so we think we can automate that better, and that's one other thing that we're working on. So that's it for the initial presentation, and now I had 2 demos of the tools and how they actually look like, because as I was saying, we not only want it to be an abstract model somewhere or a publication, but we want them to be useful. So we actually deploy them to the web directly so that they can be tried as well. And here, this is our screening for diabetic retinopathy, which I mentioned at the beginning. And here I can just select 3 fundus images. So we see we have one which is normal eye, we have one which is a small diabetic retinopathy, and one which is already moderate, which is considered already in need of treatment, right? So we really want that to be analyzed correctly. So we can just upload them, and our AI in the background will analyze the different images and provide the results to a doctor, so they can either directly accept that diagnostic after checking, okay, looks fine, perfect. But our objective really is that as this technology advances and we prove that we don't have any significant false negatives, we can actually remove the need for a doctor to revise it and use it in screening. Because here the industry problem really is that doctors in primary care, they don't know about ophthalmology in so much detail, and they don't feel secure about giving their diagnostic, so they take all of the patients that arrive and send them over to the specialist, to the ophthalmologist. And they spend a lot of time just reviewing images of eyes that are obviously normal, and so they waste a lot of time just going through one and the other. And that's what we try to fix, and we think we can do this with this solution as soon as the regulation advances as well and allows for AI, which practically has no false negatives, to be used as a screening tool as well. So here we see the moderate one, it's already classified as that high risk, while the small one has a medium risk and the normal eye has a really low risk. We can even go further into the images, and as I was saying, interpretability is really important for us. So we have this heat map, and we can see, okay, where is it focusing on to make the decision. We can even zoom in, and we can put on and off the heat map, so we see this little piece right here. And I'm not a doctor, but my co-founder has assured me that this is one sign for diabetic retinopathy, so that this can be directly checked within a tool. And the last use case which I wanted to show you, and this is also a really cool one, and you're actually probably some of the first people to see this, is we're working on a solution that allows us to automatically check the transcribe and interpret conversations between patients and their doctors, so that when you go to the doctor, you don't have to look at someone who is sitting behind a computer screen just typing away, but you can have a normal conversation with a person that is 100% focused on you, while a machine in the background is transcribing the conversation, interpreting it into the correct fields that the doctor is filling out, and preparing it so that at the end of the conversation, all the doctor has to do is go to the tool, see, okay, here I have my recording, so they could double check it. You probably don't hear it very well, but trust me, it's a conversation between a doctor and a patient, which is perfectly transcribed below here, so that they can also search for, okay, what was in the conversation. If I don't remember something in particular, they have it here. And then we have all of the results with the personal data, with the reason for the consultation. Here they had a very insufferable headache. We have all of the previous information from the person. Do they have allergies? Do they have some habits like smoking or alcohol, etc., etc. Also references to other family illness, etc., etc. Yeah. Yeah, so it depends on how you define develop. So with these natural language models, like no one develops them themselves from scratch. So if that's the question, this example is running on Whisper, which is a transcriber, and it's running on some version of GPT to do the question answering, which we have fine-tuned to fit the use case. Okay, so that's basically all I wanted to present from my side. You see here, of course, GPT on the back, which is helping us with a lot of our daily work. But from my side, that would be it. Happy to hear some questions from you. Or if not, I'll leave you also my card if you have any questions afterwards. I'm very happy if you reach out to answer all your questions, of course.
¿Qué es lo más difícil de identificar patrones en las imágenes?
Depende mucho de las imágenes. O sea, hay en algún tipo de imágenes que tienes muchísima variabilidad entre un tipo de imágenes y otro, y entonces tener un dataset decente que te cubra todo se puede volver muy difícil porque hay enfermedades más raras o versiones de la enfermedad que no siempre se muestran igual, entonces tener suficientes casos para que la máquina te lo interprete es difícil. Luego hay datasets de los que son públicos que tienen 50.000, 60.000 imágenes, pero igual de esas hay 100 que están mal etiquetadas y esas te revientan el algoritmo. Entonces muchas veces se trata casi más de los datos y de la calidad de los datos que de conseguir el mejor modelo, la última ResNet o EfficientNet B8 con mayor potencia. Casi ganas más con mejorando y centrándote en la calidad de los datos y una buena aumentación.
Y como hoy en día están abiertos bastante a los médicos y eso a coger estas herramientas, ¿les diría ponerlas en funcionamiento?
Para nada, es un trabajo de evangelización enorme, se está empezando a ver, hay cada vez el potencial al menos ya está más generalmente asumido, o sea, se acepta y todo el mundo ya va aceptando en plan de no, esto tiene potencial, pero de tiene potencial a realmente me fío y trabajo con ello en el día a día, queda mucho, pero se están haciendo avances rapidísimos, como habéis visto este último año con inteligencia artificial. Entonces, el tema es que en la medicina es a la vez una disciplina ultra compleja, donde tener en cuenta todas las variables y todas las capacidades es imposible, o sea, muy difícil por no decir imposible, pero a la vez se espera que los resultados sean completamente perfectos, que no se te escape nada porque estás poniendo en riesgo la vida y la salud de los pacientes. Entonces es como el tema del coche automático, ¿no?, de Tesla. Ya tienen un factor de 10 veces menos accidentes por kilómetro recorrido que un ser humano. Pero ¿cuál es el problema? ¿Quién es el culpable si pasa algo? ¿Quién paga? ¿Cómo se gestiona eso? Entonces, aunque como humanidad y como sociedad podríamos avanzar más en ese sentido, sí que tiene que ir con unos seguros y de la mano con unas regulaciones que no lo soportan del todo en la actualidad. Entonces, poco a poco. Muy bien, pues nada, cortamos aquí. Muchas gracias a todos. Thank you.